system, the SCADA, PLC, or we call it programmable logic controllers, and some system controls. Especially we are using these controls. These are complicated controls which we use in the STP, in the Safe Live Processing Plant here at Papua New Guinea. Now, as you can see, this is our STP which uses those systems. Mostly that system is for controlling, no? So it's for controlling. So just to give you a basic introduction on SCADA, and SCADA is a supervisory control and data acquisition. So it is a control system. It controls the whole plant. It controls the motor, it controls the compressor, it controls all the instrumentation located in the plant. Okay, basically. Now, it is an automation control system that is used in industries such as energy, oil and gas, water, power, and many more. The system has a centralized system that monitors and controls the entire sites. Okay. A SCADA system works by operating with signals that communicate by a channel to provide the user with remote controls of equipment in a given system. So, while these systems simplify a given infrastructure, their components are complex. There are 5 essential components, parts of a SCADA system. What are they? Can you give that, Gilbert? What are those components and systems? Okay. Yes. Human-machine interface. John, what is the next one?
Supervisory system.
Supervisory system. Okay. Daniel, what's the next?
Command units.
Okay.
Control units.
Remote. Terminal units. Okay. What else? Dolo? Thomas? Okay. Steven? What's the next?
Communication infrastructure.
Okay. Just to explain, a human-machine interface, you'll find it like this. This is a sample of a human interface. The computer LCD. So you communicate with that, you control it, you will see all the process and what is happening on the plant using the human interface. Now next is supervisory system. So there's a SCADA system that supervises it. There's a program. Remote terminal units, those are units located at the marshalling cabinet, at the control cabinets. No? Programmable logic controller, which is PLC, it has a program which is being loaded to the CPU, and that CPU will control all your system. Next is communication infrastructure. For example, input and output modules, control panels, displays, those are in communication infrastructures, meaning it is communicating between those components. So the HMI processes data from each type and sends it to a human operator. So you are the human operator and the HMI processes its data. The RTU connects sensors and convert their signals to digital data. The RTU or remote terminal unit. PLC are used as field devices because they are much more versatile and economical than process specific RTUs. Finally, the communication infrastructure delivers connectivity to the supervisory system and then to the RTU and PLC. So as you can see on the diagram, okay, this is your control system basic wiring practice. No? You can see a marshalling cabinet. You will find the computer, data communication cables, DCS or PLC, marshalling cabinet, field. What is that? Field racks. What is this? Field box. Okay, on the field box, the field devices are connected. What are the samples of those field devices? You studied that with Nathan in instrumentation. What are those? Level sensors, level transmitters. What else? Temperature transmitter, temperature gauges, temperature transducers, okay? Pressure transducers, okay? What else? Yes, what? Level gauge, level transmitters, yes. And those are your field devices. For example, it measures pressure, it measures temperature, and so on. But the marshalling cabinet, these are the connections between the DCS and the field box. Okay? You will find lots of cables here. You will find lots of cables here, and the DCS is connected to those cables. So basically, if you are going to look at a PLC system, you have what is so-called 4 to 20 milliamps. Did you study this part? 4 to 20 milliamps?
Yes.
To whom? With Nathan? Yes. 4 milliamps is the lowest value. 20 milliamps is the highest value. Okay? For example, if your pressure is maximum of 100 bars and your minimum pressure, okay, is equal to 10 bar. So the 10 bar will read 4 milliamps, and the maximum 100 bar will be equivalent to 20 milliamps. So meaning this is your signal, this is your representing value of pressure. But if you are going to measure on the Y, you will get either 4 milliamps or 20 milliamps for the 100 bar. You are going to connect the meter in series, or sometimes you have a calibrator that will measure that one, right? So now, this is the parts of a PLC. Okay, we have the communication, processor, and memory. We have the output modules, we have the input modules, and we have the power supply. So a PLC consists of a power supply. It is connected on the component system or on the frame itself. Sometimes we call it backplane. If you look at the back, then the memory and the processor. The processor is the one processing all the data that being sensed by the input modules and output modules. The output modules, what are sample of output modules? What is the sample of an input modules? An input modules can be an analog input or can be a digital input. Digital input means 1, 0, 1, 0, 1, 0. On, off, like a switch. Analog module, that is a certain signal. Okay? Analog module can be the 4 to 20 milliamp, can be a voltage 0 to 5 volts DC, or can be a temperature giving a certain value like an analog. Okay? Output module, we have digital output also and analog output. Okay? Digital output means it's like a switch on, off, like a bit 0, 1, 0, 1. But the output, digital output will give, if it's digital, it's 1, 0, 1, 0, or like a switch. But if it is an analog output module, it will give some voltage, resistance value, or even certain current value. Okay? So basically, as what I have mentioned, SCADA is a supervisory control and data acquisition. This is exactly our SLP. Okay, Safe Life Processing Plant being test and commissioned in Singapore and Philippines. You see this one, we assemble this one in the Philippines. And we bring to Singapore and we deliver here, then we assemble it back. Common system components, okay? Common system components of a SCADA, remote terminal units, programmable logical controller, telemetry system, a data acquisition server, and a software. So this is the sample of a human interface. Okay, you will see the tank, the utility water, okay, filtered water, the valves, the motors, the temperature being exhibited on the plant level, and what is this legend? Run, open, stop, close, trip, or fail. So, everybody okay?